This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series, session number 179. Happy Leap Day, everyone. A rare Satellite Book Club on a leap day. Today's presentation is NUCAPS profiles and gridded NUCAPS for use when convection isn't happening. We're glad to have Scott Lindstrom, a scientist and trainer from the Cooperative Institute for Meteorological Satellite Studies in Madison, Wisconsin. Our discussion will be facilitated by Carl Dierking, satellite liaison and developer for the University of Alaska Fairbanks Geographic Information Network of Alaska, or GINA. Carl is also a former Weather Service employee. Just a few reminders before we get started is that this session is being recorded. There will be an opportunity for Q&A after the presentation. Please post your questions in the chat and we will field them in the order they are asked. If you have signed in with an office account or general account, please note your name when asking a question in the chat so we can follow up if necessary. We're always looking for future presenters. Please contact the Tower S team, Kashad Bowman and Emily Maddox. If you would like to present, perhaps you have a recent presentation from the AMS annual meeting. The training team can help create training materials that may be unavailable or point you to materials you may be unaware of. Ross Van Til with the Office of the Chief Learning Officer can help with that. I'd like to thank our Tower S team, particularly Kashad and Emily. This Satellite Book Club goes off without a hitch each and every week because of them. The Office of the Chief Learning Officer, the GOES-R JPSS program, our presenter, our facilitator, and of course all of you for being with us today. Without further ado, let me introduce Scott Lindstrom, who grew up a mile from the Penn State Meteorology building. He eventually received 2 bachelor's degrees from Penn State and went on to grad school at UW-Madison, where both of his parents and all 4 of his grandparents graduated as well. Scott creates training documents, quick guides, blog posts, and visit training in collaboration with FDTD and the Weather Service. He also enjoys looking at beautiful satellite imagery and explaining the benefits of using it. Well, who doesn't, Scott? Scott, welcome back to the Satellite Book Club.
Thanks, Jordan. Okay, I feel like I should note that this is a leap day and that the next Satellite Book Club, sign up now, on a leap day will be in 28 years. That'll be in 2052. And that's notable because in 2052, GeoXO, which is the next generation satellite, will be at least 10 or 15 years old as the operational satellite. So there's supposed to be a sounder on that. Everyone will be old hands at using sounder data. So you'll be using, and the NUCAPS data can help you prepare for that future. I will not be the presenter at the next Satellite Book Club on Leap Day because I will be a little older than I am. But last week we heard from Bill Line's daughter. So maybe Bill Line's daughter can give the talk in 28 years. Why do you want to know about NUCAPS? Well, in AWIPS, there's an upgrade to NUCAPS coming, or augmentation maybe is a better word, because MEDOP NUCAPS are coming in early March. So MEDOP uses EASI and MHS and AMSU-A as the infrared and microwave sounders instead of CRIS and ATMS on NOAA 20, NOAA 21. And NOAA 21 NUCAPS are coming soon. They just passed their validation. So there will be 3 different NUCAPS profiles available for you in AWIPS, NOAA 20, NOAA 21, and MEDOP-C. So a tripling in the amount of data that you can use and to use to describe what's going on in the atmosphere. And as I said, NUCAPS are created from sounders, and sounders are coming operationally to the National Weather Service in 2030. So in 3 or 4 short years, sounder data will be appearing in the Pacific region when Himawari 10 data starts flowing. So it's not too soon to start learning how to use these data for different things. So that I'm advocating for the use of the sounder data partly in this talk as well. So MEDOP NUCAPS are already available in Alaska because it's created from direct broadcast. So here we have a MEDOP NUCAPS swath. This came from Carl Dierking. So of course, a different swath. So you have more observations that you can look at using NUCAPS data. Sometimes I see more yellow in the METOP sounding availability plots. I think part of that has to do with differences in IASI versus CRIS. So I just have them listed here. IASI has a 2x2 field of view. The infrared field of view for IASI has a 2x2. So there are 4 observations versus the 9 in CRIS, and there are differences in the wavelengths as well. So IASI looks from 3.62 all the way to 15.5 micrometers, whereas CRIS has the 3 separate shortwave, midwave, and longwave. If you want to learn more about this, I will refer you to the WMO's handy Oscar website, which I'm looking at daily almost. So you should be able to visually tell which one has created. I'm thinking the one with the more yellow here might be the METOP pass, and the one with the more green might be the JPS, the one from NOAA 20. But not all METOP-C passes are overwhelmingly yellow. This is an image from Derek Van Pelt. So sounding availability plot over CONUS, and the yellow is about where you would expect it to be. So there's the METOP-C overpass. So 1640, 1645, 1650, and here what the clouds look like. So we did have clouds in the regions where there were yellow. So to be determined exactly how much yellow will be in these sounding availability plots. But the nice thing about METOP-C is they're earlier in the morning, so you get maybe a shortly after sunrise view of what's going on, and then you have the NOAA 20 and NOAA 21 in mid-afternoon, so you have 3 discrete views of exactly what's going on in the atmosphere. Now, a lot of you probably have looked at NUCAPS. Well, I hope a lot of you have looked at NUCAPS and used for convection, and part of the reason for that, I think, is the first real good example of using NUCAPS was given by Dan Neatfeld, who was the Siouan Valley or Omaha Valley back in the mid-2015. This is an example from 2014. This was presented at a GOES-R User Readiness Conference, I think in Kansas City, maybe in 2015, where there was a NUCAPS overpass just before this high risk of this significant hail event over the Omaha forecast office. So a lot of the early, I think, emphasis on using NUCAPS was kind of driven by this one example where there was great information in the NUCAPS here showing exactly where the gradient and CAPE was if you adjusted the NUCAPS profiles. But I'm not going to talk about convection today. I like using NUCAPS for different things other than convection. Yeah, I look at it with convection too. So we had an unusual event here earlier this week where there was severe weather in southern Wisconsin, not something that normally happens in February, and I was looking at NUCAPS profiles then. But you can also use NUCAPS to do stuff like verify model forecasts. So this is an example from January of this year where precipitation was coming in. So you're looking at the Davenport Quad Cities soundings at 0Z and 12Z, and you'll notice a nice moistening here as a light snow event is coming in. So you look at the 0Z and the 12-hour forecast. So here's the 0Z initialization and the 12-hour forecast. And in between this, there is a NUCAPS pass. And you might use that to say, okay, how well is the atmosphere actually saturating as the snow starts to move in? So these are all from the Tropical Tidbits website. So at 6Z, we see that the atmosphere is forecast to have saturated. But where am I sounding? Oh, here are the soundings. So at NOAA 20 had an 8Z overpass, and it gives you information here to say, okay, is the atmosphere really behaving as the is the atmosphere really behaving as the model is suggesting it might? So it's kind of hard to see here, but I have a green point here, and then we have some yellow points extending down toward the Quad Cities. So we're just going to look at the NUCAPS profiles that are happening here, and you do see this nice saturation in line with what's going on with the model. So the NUCAPS profiles here are telling you, yes, the atmosphere is saturating pretty much as forecast. So maybe you can believe what the forecast is. Maybe you can believe how the forecast is evolving. So here we have an infrared image. I also have a radar image here, so you can kind of see the green and the yellow dots. And I'm just going to scan down the green and the yellow dots. Notice, even though it's yellow, which means that the infrared retrieval did not converge to a solution, the microwave one did. And I kind of like this because as you get into the heavier and heavier snow, even though they're yellow dots, you start to see the profile fall apart. So that's giving you some information about, oh, okay, the snow is getting heavier and heavier here, even though you don't really even have to look at the radar because you can see it in the profiles. And then when you get down to Davenport, things are getting really kind of, maybe you don't even want to believe that. But farther up, where you have the green and the yellow up in Wisconsin, you do have this nice confirmation of from the NUCAPS profiles of telling you what the NUCAPS profiles telling you that the atmosphere is evolving just as the forecast is suggesting it will. Another thing I like to use is it cold enough to snow. So if you look at NUCAPS routinely, I'm sorry about my voice, I've had a cold for like 4 weeks. You'll become familiar with the atmosphere, how they're estimating atmosphere. So the nice thing about looking at NUCAPS routinely is you get, if there are any biases in that, you're going to become familiar with it. Now, I have a nice star here on Portland, and you might be saying, well, Scott, why are you looking at Portland if you live in Wisconsin? Well, I do have a son who lives in Portland, and this son will occasionally call me and say, if the forecast is for snow, is it really going to snow here? So this was back in February of 2023. So I started looking at NUCAPS off the coast here, and I'm just looking at the gridded NUCAPS temperature here and comparing it to the 1,000 to 500 millibar thickness. And I see it's a nice correlation there. Looking at the gridded NUCAPS, very cold temperatures off the coast of Oregon. So they were in a cold pattern, and I knew it was going to start. I knew they were going to have possibilities of snow. So I started looking at NUCAPS a little bit beforehand, just to become a little bit familiar with it. So there is a lot of NUCAPS thermal information. I'm looking at 850 millibar temperature here from the afternoon pass on the 22nd. And then on the right-hand side, we just see the GOES 18 clean window. And then the 11Z pass from the next morning. And you look at that cold temperature. So it's -12 at 850 off the coast of Oregon. And those cold temperatures are moving inland. So this kind of thing makes me a little more confident when I try to give my kid an accurate forecast, because if it's not accurate, I'm sometimes told that. So there's Oregon, and here's what happened in Oregon on that day. They had 11 inches of snow, which is somewhat unusual. So the NUCAPS are telling me something about the structure of the cold air off the coast, where there really isn't a lot of there aren't a lot of observations. I like using NUCAPS data out over the ocean because otherwise you really don't have much to look at. And here's another example. So I'm looking at, this was a different date earlier. This was from April of 2022. And I was just looking at the individual profiles, and you can look at the freezing level from the NUCAPS profile. And toggling in the back, we have the 850 and the 700 millibar temperatures, also from gridded NUCAPS. So I could have been looking at those as well, but I kind of thought it was kind of cool to look at the freezing level as diagnosed from the profile. And here we have in April, there was 1.6 inches of snow in Portland. Now, I don't remember if I forecast this one correctly for my son or not, but NUCAPS did. I like to look at lapse rates where storms are developing. So just to orient you here, we're looking at off the coast, this is a 700 to 500 millibar lapse rate. And you see up way to the northwest of Hawaii, a region where there are very steep lapse rates from 700 to 500. So you might be thinking to yourself, well, I wonder if there's some kind of impulse coming in that will be developing based just on the lapse rates, and that's actually what's happening. So there was a strong low pressure system up in the Gulf of Alaska and a little something coming down on the northwest flow. But if you look at the lapse rates, you can ask yourself, well, do you think this is going to intensify with time or weaken with time because of, and when you have these very steep lapse rates, that might tip your hand in one direction, strengthening versus the other. I was just playing around with this one. It doesn't really show anything. I was hoping it would show something. So I'm looking at a layer temperature between 850 and 700. So there's this nice warm prod going up into Canada, and I thought, well, I wonder if I can see it in the air mass RGB, and I couldn't. Maybe this would show up better, maybe like against a more uniform background, like over the ocean, but not all my ideas are good ones. So I always like to compare the images as well to get a better feel of what's going on. So here's an example from earlier this week. So this is the unusual warmth and the unusual early season convective outbreak, mostly over northern Illinois. Some of it snuck into southern Wisconsin. But you'll notice the temperatures in the 60s in Wisconsin. But if you look in North Dakota, temperatures in the single digits with heavy snow. So a nice baroclinic zone. I'm looking at this thinking, I wonder what kind of things NUCAPS is going to show me. So I look at the total totals index, and it's showing me, I think I have two of them here. First, in AWIPS, you can also change the XML files, so this is all one field, but I don't mind looking at the fractured fields like they sometimes come in. So you see the instability over southwestern Wisconsin, maybe priming the atmosphere, helping you be more confident that yes, convection is going to happen later on, but maybe it's more likely to happen over Iowa and Illinois versus, say, southern Wisconsin. And then you also see the very strong cold front. You see the very strong cold front coming as well. So again, looking at just the 900 to 800 millibar layer max temperature. So it's the maximum temperature that NUCAPS is seeing in the layer between 900 and 800 millibars. You might be thinking, I never see this in my AWIPS menu, but if you go into the product browser, so in the upper left part of your AWIPS, click on it and product browser will become available. And if you go over to the grids in the product browser and you open up the long list of grids that are there, and you go all the way down to the bottom of those grids, you'll see gridded NUCAPS with a lowercase g, and you click on that, and you will have more thermodynamic variables than you have time to look at. But the nice thing about this is you have time sometimes to look at these variables when it's quiet over your CWA. Maybe it's a midnight shift and nothing's happening in the next 30 minutes. Go into the gridded NUCAPS, look at the fields there, and try to find ones that you might find useful during some kind of snow event, a rain-snow mix event. Create them. You load them up as the grid, turn them into an image, and then save everything off as a procedure. Or maybe someone in your office has done this already and you go steal other procedures. But this way you'll have a wealth of NUCAPS derived thermodynamic information at your fingertips whenever you actually need it. So it's not easy to do this when everything's falling apart on your forecast and you have to go look and see what's going on. But if you've done it beforehand, you will be able to just pull up the procedure, and there you have all this data. And again, right now there's just one one satellite getting you this, but in 3 months, you'll have this from 3 satellites. So you'll have just a lot of data to look at to really help you get a good idea of what's going on right now and what might be happening in the next, 6 to 12 hours, 0 to 6 to 12 hours. So here we have this is the, oops, these aren't the same, 900 to 800, and then this is 800 to 700 from 12 hours earlier. So I was following this as it was coming in. Carl, the facilitator today, has reminded me that NUCAPS also has trace gases. So if you want to look at ozone, of course, there's the ozone channel, this channel 12, the 9.6, but there's not a derived ozone product from ABI. NUCAPS does have that. So here we have an example of a NUCAPS estimate of ozone concentration. So it might suggest to you that there's some kind of strong polar vortex up over Quebec in this example. And then you can compare that to PVU surfaces in a model fields to get a handle on whether or not the cyclogenesis is occurring. You can compare it to OMPS data. There's a lot of things you can compare the NUCAPS to get a better feel for exactly what's going on. There's also a Haynes index you can look at. I don't have examples of this. This is not something I've actively looked at. So Haynes index is something that is used to compute the likelihood of how intense is a fire going to be. So you look at stability and moisture fields at 3 levels. I think it's 500 to 700, 950 to 850, and maybe 850 to 700, something like that. So you need thermodynamic information. NUCAPS gives you thermodynamic information, and larger values mean that active fires are more likely. But I think this is great for something like Alaska, where there aren't a lot of upper air stations. But it's not something that I have looked at personally in CONUS, relying more on model data and upper air stations. So my concluding thoughts here. Like I say, go to the product browser and investigate and just look at all the fields that are available. There are really a lot of them. I don't know if it's exciting to look to see how many there are, but it's enlightening to think about how many different ways thermodynamic information can be presented. So create some procedures that access those fields that create information over your CWA, so you have quick access to this thermodynamic information when you need it. So like I say, NUCAPS gives you a whole lot of information about thermodynamics, very useful over data voids like the ocean. So if you're in the forecast offices in Guam or Honolulu or Pago Pago or San Juan, NUCAPS is going to give you data out over the ocean where you don't have any other information. And I'm always looking for great examples. This is me juggling, not really me, but it's a metaphor. If you find an example, I'd love to see it. So just send it to me, and I'm happy to entertain any questions.
All right, thank you, Scott. Great presentation as usual. Please, everybody, stand by here for the discussion section. I just want to mention that next week, on Thursday at noon, Dr. Steve Goodman will, the senior advisor for the GeoExo program, will discuss lightning variability and change, the perspectives on El Nino, La Nina, and beyond. If you have any questions about the Tower S program or for just satellite products in general, contact Kashad Bowman or Emily Maddox. And if you could enter your questions into the chat, you can type them in, or if you want to speak to Scott directly, just mention that you would like to answer your question verbally. Okay, let's see. We got a question already from Joe. Great presentation. Quick question. Do we know how often the WFO forecasters use NUCAPS in general?
That's a good question. I know Tower S has been working on something that forgoes our data. So this is really a Tower S question. So maybe Kashad or Jordan can break in, but I don't think there's a mechanism to track, when a forecaster accesses a satellite product, that it goes into it that says, okay, it's been accessed, it goes into a database, and then someone then looks at that information and says, oh yeah, they're all using this data, we should make sure it keeps going. So how often do forecasters use it? Not sure. Hope they not enough would be my answer.
I would say that too.
Joe here. Yeah, I know that Gordon and others have done like these surveys in the past, and maybe they can ask a question like that in the future, because that's really getting down in the specifics. But it would be interesting to know, because it's really kind of a neat product. So
yeah, this is Jordan. I'll just to tie that up. We are in the process of looking at analytics for satellite data. We're not looking at who's using what, but we're looking at what's getting pulled. So kind of like what's selling off of store shelves. But we have not gotten to the point of incorporating NUCAPS into that yet. So I'm sure we'll find that answer out eventually.
Yeah, there's a few comments in the chat from Matt Melee and Monterey and Rebecca Ismaili. And it does sound like there's definitely a NUCAPS group that's making good use of the product. Do you know, I was wondering, as you mentioned briefly about the yellow versus green, do you have a feel for the yellow as far as usefulness? Microwave observations are going to let you penetrate the cloud. Do you feel there's any drawbacks to a yellow quality sounding versus green?
I think in general, for something like a layer, like if you're looking at the mean temperature from 700 to 500, and you're looking at a microwave derived value, I think that's giving you some pretty good information. If you're looking at a point value like 850 temperature, and that's it, I think you're more likely to run into something that's not going to give you what you need. So it really depends on, because a microwave observation of temperature is going to be over a fairly large layer. The infrared is also over a large layer as well, but for some reason, in my mind, I think that the microwave is more, what's a good way to put this, that's what I expected to do, is to give you a layer temperature. So I don't think it's, I think you should be cautious when you're using a variety of yellow dots, but I think you can still get really good information from it, especially, if you're looking at like tropopause height. You might have a red or a yellow profile, but you might still have a good tropopause height. So look at the actual computed values, and you can judge for yourself.
Tim Schmidt has a question. In a perfect world, how often might profiles from space be needed, especially in rapidly changing areas or events, and or to derive wind information?
Right. This is Tim warned me he'd ask this question, and this is a GXS question. Like, how often should a geostationary sounder be sampling stuff? And right now, I think the idea is to get a hourly observation. And I was thinking about this, and it seems to me that a geostationary sounder, someone is going to take the geostationary sounder data before a severe weather output, before a variety of severe weather outbreaks, and throw machine learning at it. And I think that's where the real power from the geostationary sounder is going to come. I'm pretty old school, so I don't quite necessarily understand machine learning. It sounds kind of like model output statistics to me. So maybe sounder output statistics with a better acronym would be used to use a machine learning tool to say, okay, given what we see right now in the past, this is the kind of severe weather this kind of sounder information is given us. So I think hourly globally is good. I hope there's some capability to do some kind of mesoscale sectoring, so you can get maybe every 15 minutes for sounder information as things are changing rapidly. I think that would be useful.
Okay, and quick question from Oleg Reitberg. Just wants to know what parameters are in the SKU-T plots.
Could you explain the SKU-T profile plot? What parameters are plotted? Well, this is using N# in AWIPS. So if you're familiar with N#, that's the kind of information you're going to get. So you have a dialog box at the bottom where you have things like MUCAP, precipitable water, all the different thermodynamic variables that can be derived from the profile. For the freezing level, that is also something that is plotted on the N# profile. So there's a freezing level, the -10, -20, and -30 levels as well are plotted on those plots.
What is the dashed red line there?
The dashed red line?
Yeah, there's a red line is the temperature, right? And what's the dashed red line?
Look and see what. Let's see. Where was a profile? Did I have a profile? Oh, this one. Okay.
Yeah.
So the red line is temperature, the green line is dew point, and the cyan is, I believe that is wet bulb. So you see the LCL is plotted there, minus the level of -20, -30, the equilibrium level, and the LFC.
Sorry, well, what is cyan again?
Cyan is the wet bulb.
Oh, okay. Thank you.
William Straka has a few comments. Gridded NUCAPS is available in Real Earth, and NASA Sport also has a Gridded NUCAPS page from direct broadcast. So if you want to look at some early NUCAPS from direct broadcast, you can check that out. Also, William says it's critical for the algorithm being developed for predicting pyro-CVs. That's some future development work. Sheldon asks, could NUCAP soundings be useful for locating the best snow growth areas like the -12 Celsius to -18 Celsius areas to tell you what layer has those temperature boundaries?
If you go to the product browser, you will see something very similar. I think there's a dendritic growth temperature in there. That is not something I've looked at with NUCAPS, because generally when the snow is falling, I guess I could look before the snow starts, but when the snow is falling, you're starting to lose the green and the yellow dots, and you're moving more into red dot territory, which, so there's that issue with using NUCAPS when precipitation is falling, because NUCAPS profiles really aren't meant for that kind of thing, I would say.
Maybe as a precursor, Aaron Jacobs says WFO Juno uses NUCAPS gridded data and soundings, but has seen issues in the boundary layer. A lot of action takes place that affects our weather in complex terrain, especially if snow will make it to the surface. Do you have any suggestions on what to do in those situations?
Yeah, that is a very difficult problem over land. It's not quite so bad over water. Usually the boundary layer over water with NUCAPS gives you pretty good information, and it's all related to the emissivity of the surface and the contrast between the surface temperature and the rest of the atmosphere. So if you think about it, the satellite is looking down and trying to infer what's going on. And if the surface is cold and the middle of the atmosphere is cold, it's difficult for NUCAPS for the retrieval to figure out exactly what the profile is going to look like. But if the surface is warm, like it is over the ocean and the middle atmosphere, so that contrast between warm and cold makes it a little bit easier. So, Aaron, you're not alone in making this observation. There have been examples where, you can always go into NUCAPS and alter. You can always go into NUCAPS and AWIPS and alter the boundary layer temperatures to be something more in line with reality. That's a very time-consuming process. There has been work done at CIRA by Jack Dostalik to do that automatically based on nearby RTMA analyses. That's mostly been done over, let's say, over terrain that is a little more homogeneous than you have over Alaska Southeast. So you have the unique problem of having terrain changing very quickly in the horizontal. So the volume that NUCAPS is sensing is going to have big terrain changes at the surface. So that's a very difficult problem to get around. So I think if I looked at it for a long time, I could come up with a better answer to this question. But at the moment, I don't have a lot to offer you. Sorry about that.
So there was some discussion about finding it in real Earth, and I'll leave that for direct messages. Tony points out that it's not always true that the IR and microwave sounding in a yellow is not useful, particularly for METOPS-C. In regions where green and blue are neighbors, I would at least take a look at the yellow.
Green and blue, I think.
Yeah, I'm sorry, that's supposed to be green and yellow are neighbors.
Oh, okay. Yeah.
Green and blue make yellow. Yellow and green
Right.
blue.
The point is, a lot of times in the neighboring regions where you have a green and a blue, a yellow and a green, you can look at the IR sounding that didn't pass, and it will give you good information.
Yeah, but that's not something that's available for a forecast.
Well, no, it is for the yellow. The IR plus microwave retrieval is available. That's what goes
in
out over AWIPS. You have it, as I understand.
Do you know, related to that, is are red observations gridded? Are they included in the grid, or is it just yellow and green?
Yes, the gridded NUCAPS takes all data. This was tested at HWT 4 years ago, 5 years ago, and most of the forecasters there said yes, just put it all in there, and we will use our meteorological knowledge to screen out the bad data. Otherwise, you get big holes in the data, which was more distracting than the bad data itself.
Mm-hmm. So something to keep in mind, maybe where those red dots are showing up if you're looking at a gridded field. Right.
So if you see weird things in the gridded NUCAPS, that's when you think, oh, I wonder if it's a red field. And that's why normally when I put up, a lot of times when I put up gridded NUCAPS fields, I will put the sounding availability on top of it.
Okay.
And Aaron, I see your comment. So if you have an example in the near future, let me know and I'll poke around.
Let's see. Any more questions here? There's some questions about, again, about NUCAPS in real Earth. I was going to post the link for NUCAPS in NASA Sport. They have a viewer for that. Let's see.
Hey, Carl, I have my hand up. Can you hear
Oh,
me?
sorry, Bill. Yeah, go ahead.
Yeah, I'm glad Tony Reale is here. I did want to give him some props for using NUCAPS to look at winter storm events. And so I know he gave a satellite book club, gosh, maybe a year ago about that. So that just reinforces what Scott is talking about. The other thing is the GOES GeoXO sounder will be in the central orbit, so you will not get a lot of coverage out over the water. So even under the best of circumstances, or at least the swath that I've seen from that doesn't cover much of the Atlantic or the Pacific. So keep that in mind, of the value of polar orbiting.
Thank you, Bill. I noticed you mentioned METOP C was going to be available. Is there issues with METOP B, or do you know what's the deal there?
I do not know the answer to that question.
I can address that. METOP B right now has been sort of discontinued because we can't get the QC flag, whether the IR plus microwave retrieval was successful. So if you looked at METOP B right now, it would all be yellow for the most part. And the funny thing is, again, if you look at the IR plus microwave retrieval under all those yellows, you see fairly good information. So I think METOP B right now is questionable. But I want to also point out that with METOP C and NOAA 21, I think the algorithms are going through a little bit of an improvement to the version 3.2. The NOAA 20 and the NOAA 21 move a little closer together, so they're a little more consistent than they've been before. And the NOAA 21 and the METOP C are very consistent, outside of the fact that the METOP C creates more yellows. But I really look forward in a couple of months to seeing the three satellites, particularly METOP C and NOAA 21, which I think are going to be speaking a similar meteorological language. And great timing, 10 o'clock in the morning, 2 o'clock in the afternoon, 10 o'clock at night, 2 o'clock in the morning.
Well, thank you, Tony. And I think we've run out of time, so I'll turn it back over to Jordan to wrap up.
Thank you so much, Carl, and thank you, Scott, for that great presentation. Really appreciate everyone for hanging on for the Q&A. I'm sorry, what? I can hear somebody.
Yes, this is AK. I just want to give the status for the METOP C NUCAP, which we call it HEAP. That's available on the PDA for AWIPS. It's whenever the AWIPS ready, they can get that. Not a problem. METOP B, we had some issues with the channels, the data, but they are also generating. So everything is available on PDA.
Okay.
METOP B, and NOAA 20, and we will be getting NOAA 21 soon.
Sounds good. So next week on Thursday, March 7th, we're going to have Dr. Steve Goodman, the Senior Advisor to the GeoXO program. He's going to be discussing lightning variability and change, perspectives on El Nino, La Nina, and beyond. In the meantime, if you have any questions related to the configuration of satellite products in AWIPS, potentially you're interested in when you're going to get NUCAPS for one of the satellites that AK just talked about, please feel free to reach out to Kishad Bowman and Emily Maddox. You can also find us on the NWS internal Slack workspace on the Tower-S channel. With that, we'll wrap it up for today. Once again, happy Leap Day. Thanks again for attending. Thanks so much to our presenter and facilitator. Until next week, take care, everybody.